So this video is on areas under curves. So in the last video we went through how to integrate something and how it works, but what does it actually do? So let's say we have a graph like this and we have the points labelled A and B here. And we want to find the area between the curve and the x-axis between A and B. So we want to find the area of the region here, the shaded region here. Well, we can do this because it is going to be the integral between A and B of whatever the function is, and then dx. So here's an example of this where they give us the equation of a curve and they want us to find the area under the curve between the lines x is equal to 2 and x is equal to 4. So therefore this area is going to be equal to the integral between 2 and 4 of this curve here, and this curve is x cubed plus 3x squared minus 45x plus 90, and then the dx. So let's do this. Let's integrate first. Remember, we do it term by term. So x cubed is going to be 1 over 4 x to the power of 4. 3x squared is going to be 3 times, and then x squared integrated is going to be 1 over 3 x to the power of 3, and the denominator cancels out to give x to the power of 3. Minus 45x is going to be minus 45 times, and then x integrated is going to be a half x squared, which is equal to minus 45 over 2 x squared, and then plus 90 is just going to be 90x. So this integrated is equal to 1 over 4 x to the power of 4 plus x cubed minus 45 over 2 x squared plus 90x, and then we do the square brackets, and it is going from 2 to 4. And then what we do is we just then sub in these values. So sub in 4, so it's going to be 1 over 4, 4 to the power of 4 plus 4 cubed minus 45 over 2, 4 squared plus 90, 4, and if you put that into a calculator, that's equal to 128. And then you sub in 2, and that's going to be equal to 1 over 4, 2 to the power of 4 plus 2 cubed minus 45 over 2 squared plus 90, 2, and if you put that into a calculator, that is equal to 102. So therefore this is going to be equal to what happens when you sub in 4, which is 128, minus what happens when you sub in 2, which is 102, and that is equal to 26. So the area of this region here is 26, and I talked about in the previous integration video. Go back to that if you haven't watched it and you don't know what I'm talking about. There's a really good way to check using your calculator by putting this integral into your calculator, this definite integral, and it also gives out the value of 26. Remember, you can only use this to check the answer. You can't just do that to get the answer, but it's a really powerful way to know that you've got the answer right. So here's another question where we're given a quadratic and we need to find the area between the curve, the x-axis, and the 2 points where it touches the x-axis. Now, we're not actually told what these points are, but we can figure them out by figuring out when this is equal to 0. So when minus x squared plus 3x is equal to 0, because this is where the roots will be, and then we can factorize out minus x to get minus x of x minus 3 is equal to 0. So therefore x is going to equal 0 and 3. So it's going to be 0 here and then 3 here, and therefore we know the integral that we're going to make now is going to be the integral between 0 and 3 for this curve. So minus x squared plus 3x and then dx. So let's integrate it first and integrate the terms individually. So minus x squared is going to be minus 1 times, and then x squared integrated is going to be 1 over 3 x to the power of 3, which is going to be equal to minus 1 over 3 x to the power of 3, and then 3x is going to be 3 times, and x integrated is a half x to the power of 2, which is going to be 3 over 2, x squared. So this is going to be equal to minus 1 over 3 x to the power of 3 plus 3 over 2 x squared, and then square brackets for the 3 and the 0. And then we sub in 3, so subbing in 3, it's going to be minus 1 over 3 cubed plus 3 over 2 3 squared, which if you put into a calculator is equal to 9 over 2, and then we sub in 0, so it's going to be minus 1 over 3 0 cubed plus 3 over 2 0 squared, which is just going to be 0. So therefore, in order to get the answer, we have to sub in 3 and minus the number that we sub in 0. So it's going to be 9 over 2 minus 0, which is obviously just going to be 9 over 2. So the area of R is going to be 9 over 2, and again you can check your answer by putting this integral into your calculator with 3 and 0 to check if it also gives that 9 over 2, and it does. Let's say we have an example where we want to find the area between a curve and an x-axis, but this time it's actually under the x-axis, the region. Well, we do the exact same thing, so we're going to find the integral between, so it's between a and b, and we'll do it for the function f of x dx, and then if we figure this out, it will give out the area that we want. The only thing different is that it will be negative, and the reason is because it's when it's under the x-axis, the integral will consider it a negative area, so it'll give it out as a negative number. But obviously we don't associate areas with being negative, so all you just have to do is just give the answer as the positive answer, because that's the actual area of the shaded region that we're interested in. So let's say we have another example. We need to find the area of the total shaded region between 1 and 6 of just a generic graph f of x. And part of the graph is above the x-axis and part of it is below. Now you could argue that we could do exactly what we did before, where the area will just be between 1 and 6 of f of x and then d of x, and then we just figure this out. But this won't give out the right answer, and the reason is because so for this part, this will give out a positive number and this will give out the area, but because it's below the x-axis, this will give out a negative number. It will be the correct area, but it will be a negative number. But the problem is when we do this integral as a whole, it will be the positive area here plus the negative area here, and what will happen is this area will actually subtract from this area, and therefore you will just get an area that doesn't make sense, and it will just be wrong because these two areas are not adding together. This is subtracting from this one instead. So how do we deal with this? Well, what we're going to have to do is we're going to have to find these two areas separately and consider the integrals individually. We have to do these parts separately. So how do we do that? Well, let's consider this one first. So this is going to be the integral between 1 and 3 of f of x of d of x, and this is going to give out a positive number of this area. And then for this area, we need to do the integral between 3 and 6 of f of x and then d of x, and this will give out a negative number. But then what we can do when we're figuring out the total shaded region is we can just add these two numbers together and make this one positive. So we can do a positive number plus a positive number, and this will give the total area. So this is how you figure out something like this. What you're going to have to do is you have to consider these two areas individually, because this one will come out negative, and when it comes out negative you make it positive, and this will give you the total area. And if you're not given a diagram, you may need to sketch, if it's an easy graph to sketch, you may need to sketch a quick graph to see if any of the two areas are like this, where it goes under the x-axis, because then if you just did 1 to 6 like that, you wouldn't get the correct area. You need to do it separately in order to find the total area. So here's an example of a question like this, where we have this curve here, and we can see that some of the curve lies on top of the x-axis and some of it lies below. So what we're going to have to do is going to have to do two separate integrals. Okay, so first of all, let's make this into a bit more of an easier function. So this is y is equal to x minus 1, and then these two brackets expanded is going to be x squared minus 12x plus 35, and then we can expand this bracket with this bracket to make x cubed minus 12x squared plus 35x minus x squared plus 12x minus 35, which we can simplify to x cubed minus 13x squared plus 47x minus 35 by expanding these two brackets here. So now we can integrate this a lot easier. So this is going to be, so first of all we want to find the area of the top part. So this is going to be the integral between 1 and 5 of this, which is going to be x to the power of 3 minus 13x squared plus 47x minus 35 d of x. So x to the power of 3, remember we integrate the terms individually. X to the power of 3 is going to be 1 over 4 x to the power of 4. Minus 13x squared is going to be minus 13 times an x squared is going to be 1 over 3. X to the power of 3, which is equal to minus 13 over 3 x to the power of 3. 47x is going to be 47 times, and then x integrated is half x squared, so this is going to equal 47 over 2 x squared, and then minus 35, so it can be minus 35x. So this is going to be equal to 1 over 4 x to the power of 4 minus 13 over 3 x cubed plus 47 over 2 x squared minus 35x, and then we use the square brackets. This is 5 and this is 1, and then we sub in the values of 5 and 1. So let's sub in 5. It's going to be 1 over 4, 5 to the power of 4 minus 13 over 3, 5 to the power of 3 plus 47 over 2, 5 squared minus 35. 5, which if you put into a calculator is equal to 325 over 12, and then we do 1. And 1 is going to be 1 over 4, 1 to the power of 4 minus 13 over 3, 1 to the power of 3 plus 47 over 2, 1 squared minus 35, 1, which if you put to a calculator is equal to minus 187 over 12. So therefore, to find this integral here, we're going to do the 5 part minus the 1 part. So it's going to be 325 over 12, and it's going to be minus, and then it's going to be minus 187 over 12, which is going to be equal to 128 over 3. So this is what this integral is equal to. So now we need to figure out this area here. So this is going to be the integral between 7 and 5 of x to the power of 3 minus 13x squared plus 47x minus 35 of dx, and this is going to be equal to, we don't need to do the integration again because it's the same integral as before, so this is going to be equal to 1 over 4 x to the power of 4 minus 13 over 3 x to the power of 3 plus 47 over 2 x squared minus 35x, and then we do the square brackets for 7 and 5, and then we sub in the values. So for 7 it's going to be 1 over 4, 7 to the power of 4 minus 13 over 3, 7 cubed plus 47 over 2, 7 squared minus 35, 7, which if you put into a calculator is equal to 245 over 12. We figured out the 5 before, because the 5 before we figured out to be 325 over 12. So therefore this is going to be the 7 part minus the 5 parts. So it's going to be 245 over 12 minus, and then remember we figured this out before with the last integral, so it's going to be 325 over 12, and then this is going to be equal to minus 20 over 3. So now we know the two areas, 128 over 3, and it's going to be 20 over 3 because we ignore the minus. So therefore the total area is going to be 128 over 3 plus 20 over 3 because we make this positive, and this is equal to 148 over 3. So this is the final answer. Again, with these integrals here, you can use your calculator and plug them in to see if you get out 128 over 3 and minus 20 over 3. That's a good way to check that you're doing it properly. So they could also give you a graph and then also give you a straight line, and they want you to find an area between the two. Now the key to this is basically just to look at the diagram. They'll always give you a diagram and basically kind of draw on lines and see if you can find like a simple shape that you can minus from the overall integral. So for this one, we know that the integral of the graph from here to here will give this area here, this whole area, but we only want this part here. But we can notice that this is a triangle, and therefore we can figure out the area of the triangle. And then for this one, if we do the integral from here to here, it will give the area under the curve, so it will give this area here, and therefore this here is a square. So therefore what you can do then is you can find the area of the square and then minus the area under the curve with the integral, and that will give you this area here. So this is just kind of something in which just look at the diagram, kind of look at the spatial awareness, look at what if you integrate from certain points, so for example this point and this point and this point and this point, what area that would give you, and see if you can kind of see any shapes that you can easily figure out as well. So here's an example of this. This is an example actually specifically mentioned on the spec. We have this curve and we have this line, and we need to find this area here. Now just a couple of tips for these questions in general. Firstly, they usually set up these questions so that you're able to find the point of intersection between the curve and the line. So this is quite a good place to start. So let's consider the point of intersections between the curve and the line, and let's consider the integral of the curve between these areas. So the integral of the curve, and what actually will this area be? So it would be the area under the curve between these values, so it would be this here. And now what is the difference between this and R? Well, it is this triangle here, and this is a good sign because this is quite a basic shape and we should be able to figure out the area of this shape. So what we figured out is that if we find the integral and then we find the area of the triangle, and then we minus the area of the triangle, that will give us R. I usually write a formula like this because this is quite like a good setup of where we need to go. Okay, so let's start with the integral. So first of all, we're going to need to find these points. So it's going to be when 6x minus x squared is equal to 2x. So this is going to be minus x squared plus 4x is equal to 0. Factor out minus x to get minus x of x minus 4 is equal to 0. So x is equal to 0 and 4. So it's 0 here and then 4 here. Okay, so therefore the integral is going to be between 0 and 4, and it's going to be of 6x minus x squared, the curve dx. And then we integrate individually. So 6x is going to be 6 times it's going to be half x squared, which is equal to 3x squared. And then minus x squared is going to be minus 1 times, and then x squared is 1 over 3 x to the power of 3, which is going to be minus 1 over 3 x to the power of 3. So therefore the integral is equal to 3x squared minus 1 over 3 x to the power of 3. Put the square brackets around it, and then it's going to be 4, 0. And then we just sub in 4, so it's going to be 4 squared minus 1 over 3, 4 to the power of 3, which if you put into a calculator is equal to 80 over 3. And the 0, because there's x in every single term, therefore it's just going to be equal to 0. So this is the integral, 83. So this is this whole area here. So we have the integral. So now we need to find the area of the triangle. So we need to know the base, and we need to know the height. Well, we know the base because we know this is 0, and we figured out that this is 4, so this is also going to be 4. So the base is going to be 4. And the height is, because we know that this is the x coordinate is 4, and because we know it lies on y is equal to 2 of x, we know that therefore the y coordinate of this is going to be y is equal to 2 times 4, which is equal to 8, and therefore this is going to be the height of the triangle. So the height is equal to 8, so therefore the area of the triangle is going to be half base times height, so it's going to be half 4, 8, which is going to be equal to 2 times 8, which is going to be equal to 16. So therefore, the area of R is going to be equal to the area, or the integral, sorry, so 80 over 3 minus the area of the triangle, which is 16. And if you put this into a calculator, it is equal to 32 over 3. So this is the final answer. So here's another example. So as I said before, always a good starting point is the points of intersection, because we're usually able to find these. So these are the points of intersection. And then let's consider the integral. So the integral would be the area under the curve. So we would find this area here. And you might be able to notice at this point that we have a really nice triangle here. This is a really nice triangle. It's quite simple. So therefore, hopefully we should be able to figure out the area of it. And therefore, this triangle is made up of R and the integral. So therefore, to find R, we just do the triangle, the area of the triangle, and then minus the integral. And this will give R. So now we have our starting point, so let's work from here. So let's start with the integral. So first of all, we need to find the points of intersection. So it's going to be when x squared plus x is equal to 3x. So therefore, x squared minus 2x is equal to 0. Factor out x to get x of x minus 2 is equal to 0. So therefore, x is equal to 0 and 2. So this is 0 and this is 2. So therefore, the integral is going to be between 0 and 2 of x squared plus x in terms of dx. So let's do the integral, so let's do them individually. So x squared is going to be 1 over 3, x to the power of 3, and then x is going to be a half x squared. So therefore the integral is equal to 1 over 3, x to the power of 3, plus a half x squared, and then we do the square brackets, and it's going to be from 0 to 2. So let's sub in 2, so it's going to be 1 over 3, and then 2 cubed plus a half, and then 2 squared, and this is equal to, if you put it into a calculator, 14 over 3, and 0 is the same as before. All the terms have x, so therefore it's going to be 0. So this is the integral, so we found this part. So how do we find the triangle? Well, it's a lot similar to last time, actually. We know that the x-coordinate here is 2, so this is going to be 2, and we know that this lies on the line y is equal to 3 of x, so therefore we can figure out the y-coordinate is going to be y is equal to 3 times 2, which is equal to 6. So the height is going to be 6, and the base is 2, so the base is 2, the height is 6, so therefore the area of the triangle is equal to half base times height, so half times 2 times 6, which is just 6. So therefore, the region R, the whole area, is going to be 6, because that's a triangle, minus the integral 14 over 3. And if you put that into a calculator, that is equal to 4 over 3. So just note there's kind of like a lot of similarities between the questions. The points of intersection are always really important. You always will look out for stuff like triangles and stuff like that. That's really useful, but just simple shapes like that. And always consider the integral. The integral, what is it actually finding if I find it? If I find this here, what does this actually give me on the graph? And it gives this area here, and I was able to figure out R. So here's a couple of questions on areas under curves, so pause the video, have a go, and I'll go through the answers in about 5 seconds. So for part A, we need to write down the x-coordinates of point A and B. So this is where the roots are. So this is literally just going to be where 0 is equal to x of x plus 4, x minus 2, which is the graph. So x is equal to 0, minus 4, and 2, because we can tell from the brackets by equaling them to 0. We know that the origin is equal to 0, so therefore B is equal to 2 and A is equal to minus 4. So for part B, we need to find the area of the total shaded region, with one of them being above the x-axis and one of them being below. So therefore we can't just integrate from minus 4 to 2 as we talked about before. We have to do them separately. First of all, let's write this in a more easy to integrate form. So it's going to be y is equal to x, and then we're going to expand x plus 4 and x minus 2 is going to be x squared, and then it's going to be plus 2x minus 8. Then we can expand it again to x cubed plus 2x squared minus 8x. So let's start with this one. So this goes from minus 4, remember this is 0, so it goes from minus 4 to 0, so therefore we want to integrate between minus 4 and 0 this function here, so x to the power of 3 plus 2x squared minus 8x, and then it's going to be dx. So first of all, let's integrate it. So x to the power of 3 is going to be 1 over 4 x to the power of 4. 2x to the power of 2 is going to be 2 times, and then x to the power of 2 integrated is 1 over 3 x to the power of 3, which equals 2 over 3 x to the power of 3, and then minus 8x is equal to minus 8 times, then x integrated is a half x squared, so it's going to be equal to minus 4 x squared. So therefore this is going to be equal to 1 over 4 x to the power of 4 plus 2 over 3 x to the power of 3 minus 4 x squared, and then we do these square brackets to show that we're going from 0 to minus 4. And then we sub in 0 first, but 0 is just going to be 0 because all of the terms have x in it. And then we sub in minus 4, so this is going to be 1 over 4 minus 4 to the power of 4 plus 2 over 3, and then it's going to be minus 4 to the power of 3 minus 4, and then minus 4 to the power of 2. And if you put that into a calculator, that is equal to minus 128 over 3, and therefore we need to do what happens when we sub in 0 minus what happens when we sub in minus 4. So when we subbed in 0, it's going to be 0, so it's going to be 0 and then minus, and then it's going to be minus 128 over 3 as we're minusing the minus 4 part, and this therefore is going to be equal to 128 over 3. So this integral is equal to 128 over 3. So for this part here, it's going from 0 to 2, so it's going to be the integral from 0 to 2 of x to the power of 3 plus 2x squared minus 8x, and then dx, which is going to be equal to, remember it's the same integral as before, so it's going to be 1 over 4 x to the power of 4 plus 2 over 3 x cubed minus 4 x squared, and then brackets, and then it's going from 0 to 2. Sub in 2, so it's going to be 1 over 4 2 to the power of 4 plus 2 over 3 2 cubed minus 4 2 squared, which you put into a calculator is equal to minus 20 over 3. And we said before we don't if we sub in 0, it's just going to be 0 because all of the terms have 0. So therefore, the integral from 2 to 0, so we do 2. What happens when we sub in 2? It's minus 20 over 3. And then we minus what happens when we sub in 0, which is just going to be 0. So therefore, the area is just minus 20 over 3. So therefore, the total area is going to equal to the two parts added together. So this part is 128 over 3. And then this part is going to be, we make this positive, so it's 20 over 3. And if you put this into a calculator or just figure it out, it's equal to 148 over 3. Again, you can check your answers to this integral and to this integral by putting it into your calculator and putting that function in, putting in these bounds, and it should give out the values that you got there. That's a really good way to check that you've got the right answer. So for part A, we need to show that the x-coordinate of A is 1, and A is a turning point here. So if you think back to the last set of videos, it gives us a clue by saying using calculus. A turning point exists when dy over dx is equal to 0. So let's find dy over dx. So dy over dx is equal to, and then we differentiate each of these terms individually. So 4x to the power of 3 is going to be 4 times then x to the power of 3 is 3x squared, which is equal to 12x squared. 9x squared is equal to 9 times then x squared is differentiated as 2x, is going to be 18x, and then minus 30x is going to be minus 30, and then the minus 8 just goes away. So dy over dx is equal to 12x squared plus 18x minus 30, and we need to find the values for when this is equal to 0. We'll divide everything by 6 first to make it a bit easier, so it's going to be 2x squared plus 3x minus 5 is equal to 0, and then we can factorize, so it's going to be 2x and then x, and this is going to be equal to 0. and this is going to be plus 5 and minus 1 here, because this gives the plus 3 in the middle. So therefore x is going to be equal to minus 5 over 2, and then x is equal to 1. You could use your calculator or any method you want for finding the values of x, and it tells us that x is between minus 0.5 and 2.2, so therefore x cannot be minus 5 over 2, so therefore x is definitely equal to 1. So for part B, there's quite a few ways that you can approach these. All of them kind of revolve around the idea of putting a line here, where of course this is going to be 1 because we figured this out before. I'm just going to label the other parts as well. So this is minus a quarter, and this is 2, because this makes it a lot easier, because then we can do this integral to find this area. And there's a few ways you can get this area. You can integrate this point and then kind of use the triangle in some way. But one of the biggest tips I've really got to come at with these kind of questions is really approach them with an open mind and really look at all possibilities, because there's a very easy way to do this, and that this triangle here would literally just give you the exact area for this part here. So therefore the overall area can be the integral here and then plus the triangle, and that will equal R. Now that took me a while to see as well, kind of just to see that triangle there. So again, really try and approach it with like an open mind and kind of look at all possibilities. Okay, so let's start with the integral. So we're going to do it from minus a quarter to 1. So the integral is going to be minus a quarter to 1 of this equation here, which is 4x to the power of 3 plus 9x squared minus 30x minus 8 d of x, and then we integrate each term individually. So 4x to the power of 3 is going to be 4 times, and then x to the power of 3 differentiated is 1 over 4x to the power of 4, which is equal to x to the power of 4. 9x squared is going to be 9 times, and then x squared integrated is going to be 1 over 3 x to the power of 3, which is equal to 3 x to the power of 3. Minus 30x is going to be minus 30 times, and then x integrated is half x squared, which is going to be equal to minus 15 x squared, and then minus 8 is just going to be minus 8x. So this is equal to x to the power of 4 plus 3x to the power of 3 minus 15x squared minus 8x, and then we put the square brackets. We're going from minus a quarter to 1, and then we just sub the values in. So 1 is going to be 1 to the power of 4 plus 3 1 cubed minus 15 1 squared minus 8 1, which if you put into a calculator is equal to minus 19, and then minus a quarter is going to be minus a quarter to the power of 4 plus 3 minus a quarter cubed minus 15 minus a quarter squared minus 8 minus a quarter, which if you put into a calculator, since it's okay you giving it to 2 decimal places, so this would be equal to 1.02. So therefore this overall area is going to be, when you sub in 1 is minus 19, and then minus what happens when you sub in minus 1 over 4, which is minus 1.02, which is going to be equal to minus 20.02. And this makes sense if you think about it, why it's a minus number, because remember we are actually under the x-axis here. We'll just have to make it positive at the end. And again, you can check your answer by putting this integral into your calculator and checking that it gives out minus 20.02, which it does. So now we need to find the area of the triangle. So we need to know the base, which is this, and the height, which is this. The base is really easy because this is 1 and this is 2, so therefore the base is just going to be 2 minus 1, which is 1. And the height is going to be this here, so it's the difference between this, which is the x-axis, and this, which is point A. So we need to find the y-coordinate of point A, and we know the x-coordinate, and we know the equation of the curve, so therefore we can just sub in 1, so it's going to be 4 1 cubed plus 9 1 squared minus 31 minus 8, which if you put it to a calculator is equal to minus 25, which again, it makes sense that it's a minus number because it's below the x-axis, but this means that the height is going to be 25. So the area of the triangle is going to be half times the base, which is 1, times the height, which is 25, so it's going to be 25 over 2. So the area of R is going to be the area of the integral plus the area of the triangle. So the area of the integral is 20.2. Remember, we make it positive because it's an area, so 20.02 plus the area of the triangle, which is 25 over 2, and if you put that into a calculator, that is equal to 32.52, and that's the 2 decimal places, and that's the final answer.